All right, part 3 for college algebra with Mr. Fender. Tuesday, Thursday nights, 5 to 6:15. This is Tuesday, 8:31's lecture. Maybe we can finish it up right here. All right, there's one more type of symmetry you do not see very often, but it is available, and that is being symmetric with respect to the x-axis, where you can fold it up or down this way and get one part of the graph to lay on top of the other part of the graph. Now, please note that this graph is not a function. Okay, it is a relation. Remember, it fails the vertical line test because you have x's that have two y outputs for a single x. And remember, that is not what a function is defined as. It's one x to one y. Okay, so the other thing is, in a graphing calculator, you cannot enter this in. There's not an option for an x1 when you hit the button in your graphing calculator to be able to key in your equation. There's only a y possibility, which means you have to do a little bit of algebra skill and you have to solve for y if you want to try to get this graphed on a graphing calculator, which means you have to enter in both the positive and negative versions of the square root of x once you do the solving process. Okay, because the square root of a number, this whatever comes underneath this, can be either the positive or negative versions of it. The square root of 4. Well, 2 times 2 is 4. But also, negative 2 times negative 2 is also 4. So the square root of 4 could either be a positive 2 or a negative 2 when you plug that in. Okay? So be aware of that for square roots. Okay? It's both positive and negative options. Sometimes you can't use the negatives. Sometimes you can. In this particular case, you have to include both of them. That's how we get the second part of our graph down here with the negative version of x. This part up here is the positive version. Okay, looks a whole lot like the square root function, where y is just equal to positive square root of x. Okay? So, this is what it would look like. Okay, and in the notes, right here, the graph has symmetry with respect to the x-axis. Okay, but only if you fold it upward, downward. Okay, one fold. Okay, and here's a note making sure you know that you have to solve in order for y1 to be the positive negative version of the square root of x if you were going to try to graph that on a graphing calculator. So that finishes up that particular set of descriptions and function capsules. We call all of these functions that are contained in these 7 capsules that I have listed for you as parent functions. Okay, that's going to become extremely important when you get into 2.2 and 2.3, is to understand what we mean by start with the parent function. Okay, we're talking about one of these 7 graphs that you have seen in this section. These are all known as the group of parent functions. You need to be extremely familiar with those. Okay, so one more way of describing functions. Okay, and let's get back to your notes real quick. Okay, one more way of describing a function is either an even function, an odd function, or it's neither. Okay, and you can tell whether they're even or odd depending on their symmetry. Okay, even functions will always be symmetric with respect to the y-axis. Okay, what this means is that for every f of x, okay, where you have a positive x value here, it will equal the exact same answer if you put in a negative value for x. Okay, think about the square function. Okay, y equals x squared. I can put negative 2 in for x, and it becomes a positive 4. If I put the positive version of that in, and it's a positive 2, well, positive 2 squared is also positive 4. So negative 2 squared, positive 4, positive 2 squared, positive 4. Positive 4 equals positive 4. That means your square function is an even function. And the parabola that you saw earlier in your capsule is symmetric with respect to the y-axis. That's how you know that a function is an even function. You can also do this analytically by replacing the x that's given to you with its negative version and doing the math that's there. If you still come up with the exact same answer, then it's an even function. Okay, odd functions. Okay, they will always be symmetric with respect to the origin. Okay, this is like your cubic function. Your cubic function, if you take an f of x, okay, let's say it's a negative x, and you replace it with a positive x, but you put the negative sign out in front of your entire function, okay, those two items will be equal to each other. So negative 2 squared is a negative, or negative 2 cubed, apologize for that, negative 2 cubed is negative 8. It's negative 2 times negative 2 times negative 2. You get a negative 8. Well, if I put a positive 2 in and I cube it, well, 2 times 2 is 4, times 2 again makes 8, but then I put this negative sign in front, that makes it negative 8. So this negative 8 on this side and this negative 8 on this side are equal to each other. Okay, what you need to remember is that this side right here can be rewritten as negative 1 times f of x. Okay, that negative sign that's in front of the f, there's an understood 1 there, and it is negative 1 times the function. Okay. And then when you look at some of the other functions, they are not symmetric at all, such as the square root function. It has no symmetry with the origin. It has no symmetry with the y-axis. It doesn't have any symmetry with the x-axis. It has no symmetry at all for the square root function. So it is considered neither. It is not an odd function. It is not an even function. Okay, so that's another piece of descriptor that you need to know about your capsules that are not listed there. You need to go back and label them as either being even, odd, or neither. Okay, that would be a strongly encouraged thing to do. And that is basically all of the information that you need out of 2.1. Okay, is to start learning what the parent functions look like. Make sure you start memorizing some of the vocabulary and the information contained in the capsules, and make sure that if I give you a graph of something, you can describe it as being continuous, not continuous. You can tell me whether it's increasing, decreasing, or constant. Make sure you can tell me if it's even or odd, and make sure you know which parent function needs to be used if I give you an equation. Okay, if you've got an exponent of 2, you're probably using the squared function, so you need to have that parabola. If you've got a square root, then that's just the one hump that's not symmetric to anything, that's only in quadrant 1. Okay, you need to be able to identify those things and make use of them as you see them in problems. Okay, and speaking of problems, I'm going to give you your homework, and in addition to that, you're not getting away from having your homework quiz for tonight. I need you to send me a picture very specifically of problem number 73 with all the work shown from the 1.6 homework that you did last Tuesday night. Okay, I need that in my email by midnight on Wednesday night. If I do not get it by midnight on Wednesday night, you will not get credit for turning it in. Okay, I'll be posting all of these updates on Canvas. I'll also send an email out, let you know that there's 3 parts, and that you need to pay attention to the end of the 3rd video to get your homework and what your homework quiz is. Okay, I hope to see you on Thursday, but we're going to have to wait and see what the powers that be say. We may have to do another one of these for Thursday night's work for 2.2 and 2.3. So just stand by and be prepared. As I know something, I will pass word on and make sure that you are aware. I'll send both the email and a Canvas announcement out. but please be paying attention to those means of communication that I have with you. If you have any questions or concerns, please reach out to me. If anything in these notes didn't make sense, or if you need me to go over anything with you, also email me, and I may make an addendum to answer your questions in a 4th video. All right, well, hope to see you soon. Y'all have a good night.